The first thing we want to do is follow our process. As a reminder, that is, look for suspicious traffic, identify open ports, look for data within the packets, analyze the streams of data, look for signs of compromise, draft a report of your findings. So one subtle thing when we start looking for our suspicious traffic, one of the things you might not have missed, or you might have missed, I'm not sure, because I didn't have anybody mention it in their analysis, is take a look at these IP addresses. These IP addresses in here, do they look right to you? Even the Wireshark tool is giving you red. Red saying something suspicious here. What is that IP address? It's the 224 address. That's actually multicast, and that means that the address should be used when you have bursty or not steady traffic. An example of this is we use a multicast with radar data. The one thing to take away from this is the fact that this type of address should never make it in from the perimeter. So you could tell the network team that they're not doing proper ingress filtering. That is, they're allowing inbound traffic that should never be received from the perimeter to get into your network. Not a good thing. So none of this traffic should make it into our networks. Since it has, we will continue with our process. The next step we want to perform is look for open ports. That is, set our filter tcp.flags.send equals 1 and tcp.flags.ack equals 1. We'll go ahead and forego that step because it's just a simple step to do. And we'll look at the next step of our process, which is look for data within the packets. That is the flag tcp.flags.push equals 1, and we hit enter. All these packets have data within the packets. All right. So the process now is to look for streams of data. So we've got a lot of HTTP traffic, and we'll look at that momentarily because we got some different things we'll look at for that. And as I told you before, I just scroll through the bottom window. So you can pull this up here and then pull this up, and then you can start scrolling through the bottom window down here to look at the information. And it's interesting that we got the NSA, but we'll talk about that more later. Most of the responses that you receive, right, they've got these 404 object not found. That means this query never was responded to by the server other than to say it wasn't found. So that's data, but it's not a threat to anybody who's doing analysis of an intrusion, those types of things. So if we go down here and we look at this packet down in here, we got these push packets here. So if we right click this, and we'll follow TCP stream, of interest right here is this metasploit.exe. Okay, so that's Metasploit, which is a well-known hacking tool, and of course that would be a concern. And as we come down here, we see FTP. This is some FTP information. So what we've got so far is we've got suspicious because we got a metasploit.exe file and we have FTP information in the trace, but nothing of a major attack looking platform yet because we got to do more investigation. So it's definitely a file transfer, and we got metasploit.exe. Now if we go over here and we clear this and we take a look here at packet 295 and we follow this TCP stream, now we've got a lot of data that comes in, and now here we have connected to a Meterpreter server. For those of you who know a little bit about Metasploit, that means the Meterpreter shell has been opened on Metasploit. So this is definitely a concern because somebody has compromised one of our machines. But again, the biggest concern is this 224 traffic, which is multicast, is being allowed from the internet. That's a big problem. Okay, so now let's look at another one. If we go to packet 556, and remember, that will be the start of the handshake, and the data is just below that. So in this case, the push right here. So packet 559 is the push. So we do a follow TCP stream, and now we have actual indications of another shell. So again, we have all these shells in this network trace. That means in this case, this site's been compromised multiple times. Okay, so you get that. So that's the main signs of compromise that we look for. Now the next step would be draft a report of your findings. But there's some more tricks that we want to cover here. Some of you might have done this before and maybe not, because of being a beginning level Wireshark, we didn't really get into it, but I'll get into it now. And what that is Wireshark gives us the capability when we have HTTP. If you see, we got a lot of HTTP traffic here. So if we do a TCP.port equals 80, you see we've got lots of packets. 217 out of these 581 packets, I'm getting this information down here, 217 of these packets are HTTP. Well, Wireshark gives us a great technique and a trick, which is called statistics. So if I click on statistics here, and I go HTTP requests, this will show me all the actual HTTP requests to a web server. Look at these requests to this web server 192.168.1.50. Look at all these actual requests. Script, root.exe, winnt, system32, command.exe. Them are all shell requests to a web server. And now web server should never respond to these. But if a web server responds to traffic, that response is what we call a 200 OK. We have another great feature of Wireshark, and that's the filters, of course, but we have another filter that we can use, frame contains. So if you're looking for a specific file or malware or something like that, you can use the frame contains filter. In this case, we're going to say frame contains 200 OK. When I hit enter, these are the only packets that out of all those queries responded with an OK. So the first one, right, each of these packets represents a request that was accepted. Now we continue our same process and we review the streams. And we see here this packet 58, if we right click follow TCP stream, interesting that it refers NSA, but we see here that this command.exe c plus dir, which is giving me a directory, it's accepted by this old IIS Microsoft 5.0. And not only is it accepted, but it gives me a shell. So now I've got shell access via the web port, port 80, and now I have an indication of this. All right. Now, we know we've got a compromise when we think this refer is fake. But in today's cases, we're not sure the NSA might attack us or not. But again, in this case, I created all these, so it's definitely created by me. Okay. Now, if we go back to our frame contains, and again, you just keep selecting your filters. And then I go here and I right click this packet 89, follow stream. And again, I have a sign of a compromise. So both of these are compromises. So we had all those shells that we had and we've identified already. And we also have all these compromises. So we definitely have a lot of intrusions, not only intrusions, but successful intrusions on this network. So we apply our frame contains and we go to the next packet, this one at 114, all right? And we right click it. This is another sign of a compromise. So all three of those first ones we looked at were all shells and all compromises. And now we go to this one, this packet 137. Now this one has a head command. So what this is this is manually entered by an attacker, the head command, and says, give me the header from the web server. Now this head command should never be used in a modern day web server. So this HTTP 200 OK means that this was accepted by the web server. So you could go to the administrators of this web server and say, hey, you're not following best practices of security because you just accepted a head request. There's no reason to give a head request because all it's used for is to enumerate the actual version of the web server. All right, let's look at the next one. So when we go to this next one, packet 162, this is the same concept, but it uses the GET request. Again, it's manually put in because there's not all that additional data that you see from a browser. So when you see this GET request, you get another 200 OK, but now since it's a GET request, it returns the entire page. And that's what a GET request does. This happens every time you do a browser and go to a website. A GET query is issued to that web server and it says, give me what's located at document root. Okay, let's look at another one. and this would be the last one we look at here. Follow TCP stream. Now we got the same thing, this WinNT system32 command.exe, but we get a lot of other data in here until we get what? The 200 OK, and then we get our directory. So that's another compromise. So two of these queries were just information gathering and enumeration, the get request and the head request. And then a number of these, the WinNT system32 command.exes, were all compromises. Not only compromises, the 200 OK shows it was successful. So remember, we just look at the streams. So once again, the frame 200 OK, when you have a lot of web traffic, you just put that filter in. Frame contains 200 OK, and then you go through all these and see what took place. So we did this one, we followed a TCP stream, and there it is, sign of a compromise. This pretty much covers everything in this challenge file. If you have any questions, please let me know. Also, I'll have another challenge file posted before the end of the month. Remember, it's all following this process. Look for suspicious traffic, identify open ports, look for data within the packets, analyze the streams of data, look for signs of compromise, and then of course draft a report of your findings if you're doing this in a security operations center or something like that. One last note, I know some of you were wanting the information right away, but it's better to let you work through and try to practice the process. This process doesn't change. What we change is we're going to change the actual network traffic you look at. So each time we do a challenge, you'll get more and more experience and practice at working with that. But if you really need to know, again, just contact me on LinkedIn. I'm easy enough to find on LinkedIn, or post me a message and I can give you help to find me if you can't. But I believe I'm also listed in the profile for Udemy for my LinkedIn. So again, this is the process you want to practice and follow, and use Wireshark to hack networks like a pro. Thanks.